Hey everybody, this is Larry. This is me going over Q3 of the recent Leetcode Leetcode contest, contest 213. So, furthest building you can reach. So what is this question asking, right? I think that's the number one question that you should ask yourself when you see it. And I was very slow on this, relatively, at least slower than I am normally. And also, to be honest, this animated GIF was very distracting when I was solving it. I'm just like, oh, this is really annoying. Just give me read. I need to blind this. But basically, the concept here is that if you go up, you need to use bricks or a ladder. If you go down, it doesn't matter. So you could just ignore it. It doesn't really matter. You only care about the delta. So then the question is, okay, let's say you have to go up 5 times. I don't know, just random numbers, right? Okay, let's say you have to go up n times for some n, and you could use the ladder k times, right? And how would you do it? Well, the way that you would do it is probably just greedy, right? You only use the ladder on the delta that's the most. I think that's the way we would think about it. And I think intuitively that makes sense. I mean, I know greedy, usually you're trying to prove it. For me, that makes sense because, and because it doesn't make sense to use the ladder on a shorter one, and that's some other condition happens, right? So then the question is then how do you kind of use that and furthest building you can reach, right? Well, so that's basically my thing is that, so I use a min heap to facilitate this, and min heap by its name, right? The top element is the minimum element inside the heap, but actually what we want to keep track in the heap is the top k elements, where the k element is the number of ladders, right? So basically, now look at it that way, and I put a infinite first building so that you always have to jump off, so I don't have to worry about off by 1. That's the reason why I do it here, so that I could just look at index -1. Though it made my returning the index a little confusing, to be honest. So I don't know if that was worth it. But yeah, maybe I could have just started from 1 to begin with, to be honest. Oh well. So yeah, we look at the delta. Obviously, if we go down, we could ignore it. We just continue. We look at the delta. We put the delta inside the heap no matter what. I think I had some weird logic issue during the contest. And then if the heap has more elements than ladders, that means that we ran out of ladders. So that means that we have to use bricks, right? So then now, almost kind of like in a time traveling way, you have to ask yourself, when should I use my bricks? Well, you also want to use your bricks. This is now the opposite question, right? You want to use your bricks. You want to save. You want to have as many bricks as possible, right? In a greedy way. So you only use your bricks on deltas, on all the delta that, like, on the least one as possible, right? So that's what the min heap is for. Once we ran out of ladders, we have to use bricks, and we use bricks retroactively. You can maybe even fly backwards, use the brick, and then get the ladder back if you want to think of it that way. And we use the bricks. We pop, and anytime we run out of bricks, then we cannot go any further. So we return this index -2 because it's off by 1, and because you have to, the farthest you can go is the previous one, because you cannot stay in the current index. And if you could get to the end, then it's just this thing. Yeah, so basically the idea is, again, greedy. I like this problem. I was a little bit stumped by it, to be honest. A lot of people did it really quickly, though, so sometimes that is what it is. But yeah. So we just keep on using bricks on the things that require the fewest bricks. That's kind of the trick to this problem. You can watch me solve this problem live during the contest now. Okay. It's great, or you can do listen. You can use 1 ladder or delta bricks. Current height is less. Okay. What is n? N is pretty high. Okay. Don't know that I understand this problem. Oh, so you could do bricks or ladders. That's the choice. Why is today's contest so weird? DP is n squared, but it's too slow. Okay, I think I got it. But okay. So basically, let's see. Okay. Four. So if height sub good else see the delta. Oops. Yeah, okay, fine. Insert whatever. Okay, otherwise this is not right if this is going down, right? This is going up. If greater than double. We want to put, yeah, okay. So this is a min heap. Yay. X. Okay. Yep. Something like that. 8, 10, 5. That's not right at all. But that's not the issue. 4. How do we even get 4? This is going up. This is positive. Well, that's weird. So, oh, whoops. This is. No, I don't even need this. I'm dumb. 5, 8, 4. Last index. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord, and let me know what you think about my explanation this problem. Every question you ask, I'll get better at answering them in the future preemptively. I'll see you later. Take care.